problem different from anything that we've done up to this point? Quince. 7. Yes, they're both different, right? You have a 4 and a 3. And as we have modeled in the first 1.5 lessons, all of 1 and now half of 2, what do you need to do in order for the model to work? Whether you're using number line or you're using fraction bars, what must you do first? Go ahead.
You need to make common denominator.
You have to get a common denominator. So, you got one with a 3, and you got one with a 4. What are you supposed to do? Yeah, how do you do that, though? Can I ask you this? What should the common denominator be? Squirt. How did you know it was 12? That's the easiest way to do it, is just take the denominators that you have and multiply it, because then you can scale them both up to get a like denominator of 12. It is. Okay, have you learned in elementary school LCM, least common multiple? Some of you have, and some of you haven't. It does get done. It does get done in module 2 in 6th grade, but they do it too late, in my opinion. They do it towards the end, and by the time we get to it, we've already kind of done it, because you need to get that least common multiple in order to do least common denominator. And that's a bunch of words. Let me make it simple. If I give you a 4 and I give you a 3, watch me. 4 and 3. What is the smallest number that 4 can go into and 3 can go into? That would be 12. That's what LCM is. Can I ask you a question? Would 4 go into 24? Would 3 go into 24? But not the lowest number. You want the lowest number, preferably, that 4 and 3 goes into. Now, in this case, it works by just multiplying them together, right? Right? That's not always the case. You just happen to get lucky with that one. What if I tell you, ready? 3 and 9. What's the lowest number that both goes into? See, that's the common thing. What's 18 would work. It's not the lowest. It's the second lowest, if that helps you. 9, right? One of them happens to be 9, and 9 can go into itself. Okay? What about 2 and 7? It happens to be 14. That's one where you can multiply it together. All right, so when I know that my lowest common multiple for 4 and 3 is 12, watch what I'm going to do. Because this so closely correlates to what we do with ratios. All you're really doing now is scaling up. Kind of maybe should have done it underneath, but I'm going to do it this way. What's the constant in 3/4 and blank 12ths? What is the constant? What's the constant? Take a look at my arrow. 4 times what makes 12? My constant's 3. So, like I did with ratios, take my 3, multiply by 3, my constant. That's okay. And we've made an equivalent ratio or fraction for 3/4, now called 9/12. Divided by, I know you haven't seen it like this, but I'm kind of just trying to make the connection with colors here. Make a new equivalent ratio for 2/3. Who can do it? Go for it. Okay. And then do what with that 4 with what? Not yet. My constant's 4, Sebastian, but I still got to do something else in order to get my numerator. Do you see it yet? What did you do when you had to take 2 to 4 as a ratio and scale it up to 12ths? What did you have to do to the top? Brando. Oh, how quickly we forget. What are you going to do? Right, 2 times 4 will get you 8 as the top. Okay, 8 twelfths. Okay? Now, what I did was I didn't look ahead. This is all should have been done down here. So I'm just going to rewrite my new fractions. 9 twelfths is equivalent to 3 fourths, and 8 twelfths. And if we go back to the original, we were asking how many 2/3 are in 3 fourths. I'm jumping ahead. I hope that doesn't throw you off. So now we've rewritten them. We have a nice like denominator. What's my think statement now? That using the new fractions, how many what and what? L. Good. Okay, let's model it. Here comes your first question. I'll give you a candy if you can get this. I'll give you a candy because this is the one where you got to really think before you can do it. How many, in a number line, how many lines do you need? It's a trick question. Do you know? Do you know?
12.
Do you know?
Anything more than 9.
Do you know?
24.
Do you know?
Okay.
Do you know?
13.
Do you know?
Or this.
Do you know?
9.
This is my horse right here. Say it.
16.
Go get it. Yeah, 16. You need 16.
Pretty obvious.
You'll see it when I model it. What are you leaping by? You're leaping in 8/12 leaps. So, and if you still don't see it, let's model it. What's this first line right here?
0.
Thank you for remembering. 0 is correct. And let's do all 16 because you will see why it's 16. Does anybody see the mistake I just made? Yeah. Yeah. Guess what? Guess this is why I got a pencil. I just made a mistake. I need 16 lines, no doubt, but I'm not counting in eighths. I'm counting in twelfths. Guess what? Erase, erase, erase. Sorry. However, I was right, and Eleanor was right. The first is always 0. I'm keeping everything above 12 twelfths. I'm keeping it as an improper fraction because it's you'll see it's not necessary for me to change it over. But let me ask you before I do this, do you see why you need 16 yet? Where's my go-to? There's a couple of days ago that I introduced this terminology. I'm going to go to you, Soph. Where's my go-to? And by the way, it's 9/12 divided by 8/12. My go-to. Everything the next 2 weeks is going to be, where's my go-to? What's my leap by? Help or you want to go? Or more time? Yes, 9/12 is my go-to. Make a line at 9/12. Just do that. Doesn't even have to be dotted. What's my leap by? Obviously what, Kate? 8/12. Let's do the first leap together. I get one full leap, no problem, right? There it is. Yes? 1 and something. The second leap is a partial leap. The second leap takes me to where? It's going to overshoot my go-to, but let it overshoot. Where's it going to go? All right, dotted line is 16. There it is. now, this is the hard, in my opinion, for sixth graders, this is the hardest part because it's one and something. That something is the hardest part for sixth graders to understand. Hmm. I'll go around the room again. Just shout it out. I'll tell you who's right, who's not at the end. Uh, Brando. Nate.
1 1/8 or 1 and 2/16.
Ryan.
1 1/16.
Karsten. Meals.
1 1/8.
Quince. Squirt. Willie. Madison. Soph. So far, it seems like we're split between two most popular answers, right? 1 1/8 or 1 1/12, right? One of those two is correct. Okay, so you kind of got to get the idea in the remainder here, this one and whatever. Get get twelfths out of your head, so, for now, because all I care about is when I make that partial leap. If I were to complete the leap, how many steps would it take me to get from here to here? If I were to complete that leap, how many steps would it take from here to here? And it's not 12, it's how many? So it's something out of 8. Ready? This is my go-to. That is 1 out of 8. 1 and 1/8 is pergalicious. And other licious too. Okay? That's the part, no pun intended, that's going to be a leap for you to try to figure out that partial leap. Yeah, you would have been good too. Keep it simplified as 1 and 1/8 if you can do it. Okay? It's tricky. Understanding this partial leap takes practice. 2/16 would work too. It would. Absolutely would work because you would reduce it to 1/8. Okay, so 1 and 1/8. Like I said, this understanding that partial leap will take time for some of you, for about half of you. But those of you that said 1/12, do you understand why it's 1 and 1/8? Only way to get better at it is practice it. Okay, you want to work on your own? Let me just take a look for a minute. Wait, before you go. For number 1, do you have a common denominator? So you're good. What do you have to do at number 2 before you can work? Let's do that as a class. At least do that as a class first. Grant. Yeah. Change it to what? Which is? Okay, so this one you'd have to change to 9/5 before you can do it, and then you can model it. Note, they're all number lines. Practice those number lines. I think they'll work better. For number 3, can you leave it as is? What do you have to do? This is now, Carly, page 9 we're on. What do you have to do with one of those fractions? Nate. Okay. What does that become over 4? Right, because you are multiplying the denominators by 2. Do the same thing to the numerator so you get 12. This stays as is, right, Snake? Okay, that one's good. Same problem. All right, what about this who's he what? Ave. And that gets you what? Okay, great. And then I'll leave number 5 all to your wherewithal to see if you can do it. So I'd like you to get through page 10 by the end of the period. Yeah, work in your groups. Yep. 8, 9, and 10, right? Is that what you guys are doing? 8, 9, and 10? 8, 8 9, 10.